Okay, it's time to start the session on well-being. We have three presentations, so that means we have relatively room for more discussion maybe. And I'm Takeshi Kurata from ASD Japan. Okay, then let's get started. First speaker is Forrest Lialokapis, right? Okay, so let's start.
Okay, thank you.
Yeah.
Welcome, everybody. This is an idea we have been working at my institute, it's Science Center of Excellence, for the past 1.5 to 2 years. And it's a collaborative work with my team. Haris Psalidopoulos, the second author, was the developer of the application. Sofia Pali did the design study and the qualitative analysis, and Marius did the quantitative stuff. So the idea is, this is our center. We are located in Cyprus. It's a research center of excellence. And the question is, everybody is working, I suppose, long hours in the office, and at some point you want to have a break. For you, what's the best strategy to get distressed or try to chill out a bit? I mean, in my previous position in the UK, my colleagues were going for a pint of beer. Maybe that's not the best approach in the middle of the day. But every person has a different, probably, approach to that. And we know that from literature, VR is being used more and more to support people as a tool in the workplace. And again, we know that we can help knowledge workers to detach from the workplace. This is one of the limitations of the study, and the big question, I'm going to leave it for the end for question, is whether VR is the best medium, because we didn't compare VR with anything else. Somebody might go for a walk or read a book or watch some YouTube videos or whatever else. But the idea is, in this paper, we're using VR to detach from the workplace if you're getting overwhelmed, overloaded, and stressed. So at the moment, we know that the workplace tools focus on a single activity, and most of them are doing meditation or some sort of exploration of nature walks. But we found that there are several research gaps. First of all, the studies don't really focus on the multifaceted and fluctuating nature of the workplace well-being. And secondly, most of the studies focus on the evaluation stage and exclude their perspectives from the design process. So what we did is we started from the design process and trying to understand what are the main problems, and then we designed the application. So there are several needs that knowledge workers have. One of that is the mental overload from the different tasks that you do. I suppose most of you are doing multitasking. We're working long periods, and we have physical inactivity. I'm wearing a smartwatch, not today, but it says to me after 2 hours you have to get up and do some movement. And also irregular schedules and unpredictable stress peaks, which happens during a very demanding work. So we have three research questions. The first one is we try to address on this paper: which aspects of workplace well-being can VR address? The second one is how the VR experiences can be tailored to reflect the personal and organizational needs of the workers. And finally, the design elements and functionalities which are more effective. And we have three main contributions. We identified, I'm going to present them in the next slide, 6 design requirements. We designed and developed the VR application. And finally, we did a mixed methods evaluation. So this is the overview of the 2-phase mixed method study. We started with semi-structured interviews to gather the requirements. Then we did the application. And finally, we had the familiarity session of the development and evaluation and the results. So in the first part, on the semi-structured interviews, we interviewed 5 male and 5 female participants It was done at Science in Cyprus, as I said, and we had participants from different countries, so the population was not equally distributed, but we had, I think, more than 10 different countries. And the results are presented in the next slides. First of all, VR should support a range of well-being needs. The second one is that VR should offer both structured and unstructured activity options. Next, VR should enable short and focused sessions with minimal disruption. Moreover, should offer a diversity of environments and should be multi-purpose. Finally, VR should provide personalized and context-aware recommendations. So based on these requirements that we gathered, we developed the application. And we had 3 different tasks: stretching, meditation, and exploration. This was based on the requirements that we collected, but also on the literature. And we designed 4 different environments. I'm going to show you quickly the 4 different environments. There is a debate. I'm going to mention that in a while. So we had forest, snow, beach, and abstract environments. You can get a quick snapshot of the different environments. So how is the application working? You can get a glimpse from the video. So you select from the 6 different activities that we proposed, and then you get some AI personalized reply. So we also used AI, and this is, I think, one of the most obviously hot topics that everybody's working on AI nowadays. So you get some personalized answer, and I will show you also the work that we didn't transfer the whole application of another project. This work has been funded from partially from a European project as well. So you get the personalized answer depending on the selection you want to have, and then you can, here you have a free exploration in the forest trying to de-stress. So in terms of the AI, this is that we didn't transfer the whole technology from this project. Initially, I wanted to transfer everything, but in essence, we're using personalized agents in order to, first of all, this is applied in education. So the teacher can upload a PowerPoint presentation, and then ChatGPT is interpreting the slides. And also
in this part of the presentation, we will discuss the applications of computer graphics, display devices,
questions.
the random and raster scan system, graphics input devices, and graphics software and standards.
The whole solution into the well-being application, but at the end
is the process of generating,
we thought it's going to be too complicated, too complicated for that.
Pictures,
so we focused only on bringing a part of this technology into the project, and this is the personalized
computer graphics allows us to express data in pictorial form, presenting objects
trying
as a
to be the
collection
same
of
for everybody,
picture
because as you know,
elements known as
ChatGPT has
pixels.
several limitations.
It allows for high-quality graphics displays on.
Another interesting thing that you can do is you can have, for example, multiple agents in AI. This is more into cultural heritage.
The sun is
so you can allow AI, if you want to start discussing a topic. This could be, in this case, it's cultural heritage, but we were thinking of porting that into the application, having 2 or 3 agents helping you or discussing about different strategies for well-being in the scenario.
I can't believe
and
I'm
then,
walking the same streets as
of course, you can intervene
ago.
and ask questions.
It truly is a remarkable feeling.
So in this case, we limited the AI interaction
I'm so
into
glad I decided to
a few minutes, couple of minutes, and then you can start asking questions.
I'm sure you'll find.
So both agents can start replying to you.
Hello, dear traveler.
Hello there. How can we assist you today?
So you get a glimpse of
can you
what is
recommend
possible,
any good food
and this is
here
going
in
to be
Nicosia?
probably incorporated into the next paper we're going to do.
Certainly. Traditional Cypriot cuisine is a must-try in Nicosia.
Okay.
You-
Next, we did an evaluation with 35 knowledge workers from science. And we had initially for 20 minutes the familiarity session. And then we started with the trials. And finally, we collected from different questionnaires data. We used several questionnaires, as you can see here. And at the end, we had some interviews. So one of the interesting results is the time spent on the 4 different scenes. This was a shock for me, mainly because I come from Greece, Mediterranean, and for me the most relaxing scene is the one which is called the beach. So this is a relaxing scenario for me, but maybe because we did it in Cyprus and we don't have a lot of forests or none, and maybe we don't see snow once every 10 years. That was ranked higher. As I said, it was a surprise for me. Also, positive results. We saw that we have comparisons of anxiety before and after, and we can see the increases in mindfulness, states of mindfulness, overall awareness, mental engagement, and bodily presence. So you can see differences before and after, and this was a short, quick exposure in VR. So the results we got, summary is that VR can support workplace well-being. So we got some positive results there. It works best when it's flexible and easy to enter or exit. When designing VR for knowledge workers, we should think about the how, the when, and the why. And concluding, as I said, even if a brief use of VR is applied to the workplace, we demonstrated you can improve mindfulness and reduce anxiety, promote agency and playfulness. However, limitations occur in personalization and autonomy, and structure and openness. And in the future, apart from the AI integration that I'm really pushing to be included, we want to explore adaptive VR that responds to users' changing needs. So that's it from me. Thank you very much. I try to be on time.
Okay. Thank you. Yeah, we're gonna have a question and answer. Okay.
Thanks for the interesting presentation. I was wondering, you showed, for example, the forest scene that was clearly a virtual forest. Do you think if you had maybe a more realistic forest or something that is familiar to the user that they actually have seen outside, including also the realistic soundscape, do you think that would affect the results?
It's a good question. We mentioned that on the paper. Personally, I am a computer graphics person. I like realistic scenes, but after a big discussion with the team, we wanted to avoid uncanny valley effects. So we tried to make it on purpose, not very realistic. So that was the main reason. I personally disagree with what the team said, but it was a team's decision, and we went for non-high realistic on purpose. I would prefer to have very realistic scenes.
Okay. Any other question?
Oh, thank you for this very inspirational presentation. I was just wondering, because you mentioned that you personally come from Greece and you like the snow scene more, and you're
Not the snow.
Sorry,
the beach.
forest. Yeah, the beach more, and the other one likes the the snow scene more. So I was wondering, have you ever observed any cultural differences in terms of the users, or maybe you're testing in the Cyprus working environment, so you haven't seen that much of differences?
Before I moved to Cyprus, and first I was in the UK, and then I was in the Czech Republic. We did another study for medical purposes, and the most relaxing scene there was a park. People were exposed to the park, so I think there are huge cultural differences. If I remember correctly from the studies, the big majority of the participants wanted to relax in a park. Half of the population doesn't know how to swim because there's no sea in the Czech Republic. But I was expecting, maybe it was the sample that we picked in the office, that people would like to go to the beach. We have a very high temperature in the summer, so everybody's rushing to the beach. Even now, people are swimming. But maybe there was the effect, the opposite effect, that because most of the island doesn't have forests, or we see snow very rarely in Cyprus, maybe they wanted something different to, to relax. And this is something which is very interesting to explore the cultural differences in the future. Thank you.
Okay, so then thanks to speak again. Thank you.
Thank you.
Good morning, all. I'm Michele Gattullo from the Polytechnic University of Bari. I will present this work entitled Can AI Inspire Biophilic Design in Immersive Virtual Reality Workspaces to Enhance Well-being? This work originates from a series of considerations. Smart working is becoming increasingly popular in many companies, and immersive virtual reality can facilitate this shift, offering the possibility of customizable working environments ready for a usage in the metaverse. In this context, Industry 5.0 suggests prioritizing worker well-being. Then, since we observed that the biophilic enrichment of real working environments has a positive effect on worker well-being, it's reasonable to promote the use of biophilic elements also in XR working environments. However, few studies clearly demonstrated in the literature a positive effect of well-being also in virtual working environments, and they mostly were based on subjective measurements. Therefore, the first research question of this work is, can the biophilic design of EVR workspaces improve user well-being? Hypothesizing a positive effect of biophilic design also in XR working environments, the biophilic design remains challenging because knowledge and time is required for the placement and the selection of the biophilic elements. The use of generative AI can help to speed this process, but AI-generated graphics can deviate significantly from the real environments. This deviation can regard spatial properties with the biophilic elements that can overfill the environment, temporal properties with biophilic elements that can appear and disappear in the environment, or with animations, for example, a rapid growing of a plant, and appearance properties with the biophilic elements that could not resemble real natural elements. In this work, we focused on the spatial properties. Then the second research question for this work is, can AI inspire the biophilic design in EVR workspaces properly? To answer these research questions, we evaluated the user well-being in three experimental conditions, one without the biophilic design and the other two with two different biophilic design approaches. These experimental conditions were applied to the same scenario of a virtual office. The biophilic elements used in this work were limited to plants that are mostly used in indoor environments. We used the green leafy plants classified into four main categories: table plants, floor plants, hanging plants, and green walls. The first experimental condition consisted of a normal office without any plants that was used as a baseline. This office was equipped with furniture in shades of gray so as not to influence the user's impressions of the environment in terms of color and texture. The second experimental condition consisted of the same office but with plants that were placed according to the recommendations of a focus group of experts in the field of design and VR development. These 13 participants of the focus group first designed individually the environment, then they jointly formulated these recommendations. For example, as regard the hanging plants, they recommended to place just one plant above each desk. The third scenario consisted of the same office, but with the plants that were placed following the suggestions of AI-generated graphics. We started from, we simulated in this workflow the workflow that a non-expert designer could accomplish. We started from a very basic prompt to which we attached the 3 screenshots of the virtual environment from different perspectives. Then using GPT-4o through the E3, we generated several pictures. We replicated several times the prompt. And from the visual analysis of these generated pictures, we extracted some recurring patterns regarding the placement of the plants, and then we manually placed the plants according to these patterns. We designed an within subject experiment where the 20 participants performed each of the 3 experimental conditions. The test was composed of 3 main stages. After an initial phase of preparation, the first stage of rest starts, during which users stayed relaxed with their eyes closed. Then there is the second stage of stress, during which the users performed a stress test, namely the MIST test, which consists of algebraical operations that lasted for 9 minutes. Then users were equipped with the VR headset and assigned to one of the 3 experimental conditions. This entire procedure was replicated for the 3 experimental conditions. So they were exposed to the virtual reality environment for 10 minutes. During each stage, we acquired physiological signals of ECG and EDA. At the end of each stage, users filled a brief survey to assess their perceived state of anxiety through the STAI questionnaires, their perceived pleasure through the SAM questionnaire, and at the end of the EVR exposure phase, they also estimated the perceived time spent in the virtual environment and the sense of realism and present through the SUS questionnaire. From the analysis of the ECG signal, it was possible to extract 5 physiological parameters. However, only for 2 of these we found significant results, in particular for the average of normal to normal intervals and average instant heart rate. We found that there was only for the biophilic environments a significant improvement in the relax, passing from the stress to the EVR exposure stage. A similar result was found for the STAI score and the SAM score, so respectively for the calmness and the pleasure sense. These results allowed us to answer affirmatively to our first research question. As regards the second research question, we found similar behavior between the 2 biophilic environments for all the measurements, including the perceived time in the virtual environment. But as regards the sense of presence, so the results of the SUS score, we found that for the AI-inspired biophilic environment, there was a significant reduction of the sense of presence compared not only to the other biophilic condition, but also to the non-biophilic office. So a question may arise spontaneously. What happens if we would refine the prompt? We did it. We included the recommendations provided by the experts in design in the prompt, but we found that currently these recommendations are not faithfully followed. For example, as regards the hanging plants, there is more than one plant above each desk. So we concluded that at the moment, AI always tend to overfill the environment, and this is the main cause for the reduced sense of presence and realism for this kind of biophilic design. So we can conclude saying that for sure the biophilic design can be encouraged also in EVR working environments because we found that the exposure to biophilic environments significantly improved the well-being. On the contrary, in a non-biophilic environment, it was harder to restore from a stress condition and time passes more slowly. At present, using AI to speed up the biophilic design in EVR workspaces is not an affordable approach because even if there were no clear differences between the two biophilic conditions, so the expert-guided and the AI-inspired designs, we found a reduction of sense of presence and realism in the overdense AI-inspired layout that may cause a potential decrease of work performance. In this work, we focused only on plants as biophilic elements, so future works will explore also other additional or alternative natural elements. We could investigate also the temporal and appearance properties that were not considered in this study, and we are developing an EVR test bed where there will be the possibility to accomplish manual tasks that were not considered in this study. There is the possibility to customize the surrounding environment and to place the biophilic elements, as this video demo shows, to create different biophilic designs. And we will release this test bed to also allow the scientific community to make their own experiments. That's all. Thanks for your attention.
Okay, thank you. Time for discussion. Any question or comments from audience? No? I think three presentation in this session is relevant, right? So that each presenter should have some question maybe. But okay, any question? Okay, yeah.
Thank you for the presentation. I just have one question about how this can be used. Is this for to be immersed during breaks or during completing some works in the virtual environment, or how do you see this environment can be used?
Yes, what we are trying to propose is to use virtual reality, also augmented reality, not just for the primary task, for example, to suggest procedure for an operator, but also for these secondary objectives like the well-being. So the presence of these biophilic elements is not important for the primary task because there are no further improvement, but it's important for the well-being. So this is our hypothesis, and this is what we demonstrated with this study. So in future developments of XR scenarios for any purpose, medical applications, education, maintenance, so it's a very general purpose, this study. We can use this biophilic design suggested by the recommendations of the experts to place the plants in the virtual environment. And what we are trying also to make in this wide research is to use these biophilic elements also in AR applications With the real environment, where there are not only the instructions for the operators, for example, in augmented reality, but also some virtual plants that are placed in the real environment in this case.
Thank you.
Thank you.
Thank you for the interesting talk. I was wondering, with your future research, would you also consider adding some elements that may be like slightly less realistic, like huge flowers or enormous mushrooms, or things that may probably, you know, make people feel more playful or creative, maybe even?
Yeah, this is what we could address, because the use of virtual elements rather than real ones. In the real environment, we have the constraints of the reality, but in the virtual environment, there is no such constraint.
Yeah.
So we can explore also these fantastic elements to, for example, provide the users with something that could engage them in the accomplishment of a task, or to be more creative, as you said.
That sounds so much fun. I'd be really interested to see what would be going on. I'm also imagining like a combination with the previous talk, where, I don't know, like you say, in virtual reality, there's no real limits. So you could also imagine having the whole office equipment installed on a beach or in a forest.
Yes.
So
yeah, it's something that inspired also us in this research. So when we talk about teleworking or remote working, you can work even immersed in an environment that is pleasant for you. For example, a beach, a forest, like in the previous talk.
I'd love to hear more about that. Thank you very much.
You're welcome.
Thank you. So one more last question.
Thanks for your presentation. I have question about the AI model. You said AI model overfill the environment.
Yes.
And you use the DAL-E model, and I think you said the prompt does not matter with the overfill problem.
Mm-hmm.
So have you ever tried something other method to solve this problem?
No, because we wanted to mimic the workflow that people without experience also in this tool, AI tool, could do. So we deliberately used a very basic prompt just to create inspiration. I'm not an expert. I work for this first time on the development of a VR scene. I asked ChatGPT how to create a biophilic environment, and this is the result. So this is just an initial research to verify if the AI-inspired layout could work in this context. But for sure, there could be some methods that could optimize the result of the biophilic enrichment. And I think that also in the future, there could be an automatic insertion of the biophilic elements according to a more realistic setting using the AI. So I think that it could be possible.
Thank you.
Okay, let's thank speaker again.
Hello, everyone. My name is Jessica Kim. I'm from the University of Calgary. I am a first-year master's student, and I am here on behalf of my co-authors to present our paper, Experiencing Immersive Virtual Nature for Wellbeing, Restoration, Performance, and Nature Connectedness, a scoping review. So we know that nature reduces stress, restores attention, and builds connectedness, but urbanization, mobility limits, and even climate disruptions are making these benefits harder to access. So as access to real nature shrinks, the question becomes, how can we still deliver its restorative benefits in a world that needs them more than ever? Immersive technologies like VR and AR offer a promising alternative, scalable, customizable, and increasingly available. The problem is that research in this area is fragmented. Studies use different designs, populations, and measures, making it difficult to know what truly works. Our work addresses this gap by synthesizing the evidence, showing where virtual nature already proves effective and where future research needs to go. So I wanted to start off with a bit of background. Research in this field builds on two major theoretical perspectives. The first is Edward O. Wilson's biophilia hypothesis, which is the idea that humans are innately drawn to connect with nature and living systems. It suggests that even digitally mediated environments can trigger this affinity. And the second is Kaplan and Kaplan's attention restoration theory, which argues that natural environments replenish our attentional resources and reduce fatigue, which explains some of the improvements seen in these XR studies. These two theories frame much of the research on immersive nature, and you'll see echoes of them throughout the outcomes I'll review. But despite these strong theoretical foundations, findings across the literature remain inconsistent. Different designs, measures, and outcomes make it hard to form a clear picture. This gap motivated our scoping review, where we systematically analyzed 55 papers to see how virtual nature affects well-being, cognitive restoration, connectedness, and health outcomes. The search strategy combined three key themes: nature connectedness, immersive technologies, and health or well-being outcomes, using the following search terms shown. This review followed PRISMA guidelines. We began this search with 5 databases, retrieving 484 records. After removing duplicates, irrelevant sources, and short papers, 60 remained for full text screening. 18 were excluded for not meeting key criteria, leaving 42, and through citation chaining, we added 13 more for a final set of 55 studies. The subsequent review was organized according to 3 key research questions. First, how immersive technologies have been used so far to promote well-being and nature connectedness. Second, what outcomes and trends emerge when we look across different applications. And third, what limitations and gaps are holding the field back. These questions will also structure the way I'll walk you through the findings today. So to answer research question 1, how XR has been used so far, we see some clear trends. Almost every study used VR, with AR and MR almost absent, even though they could deliver contextually embedded real-world nature overlays. Most designs relied on visual and auditory channels. Only 2 studies added scent, and none incorporated haptics, meaning the multisensory richness of real nature is underrepresented. Interactivity was rare. Just 2 studies allowed embodied or goal-directed interaction, while most were passive viewing experiences. And in terms of exposure, the majority were short, single sessions lasting 5 to 30 minutes, with only 4 studies testing repeated longer-term use. And finally, participants were mostly university students, with only a handful of studies including patients or older adults, and very little representation of other groups. So that's how XR nature has been used so far. But how effective are these studies, and what benefits actually emerge? That brings us to our second research question: what outcomes and trends do we see across the literature? To address research question 2, we conducted a qualitative synthesis of the 55 papers. During the classification process, we grouped studies by their dominant focus, which emerged through recurring outcome measures. From this, 6 thematic categories took shape organically: emotional well-being, stress reduction, restorative benefits, cognitive performance, attention recovery, and nature connectedness. These categories reflected recurring patterns in study objectives and measured outcomes, forming natural groupings around emotional, physiological, and cognitive implications. Together, they provided a comprehensive structure, with all studies fitting meaningfully into at least one theme. I'll now walk you through each category in turn, highlighting key findings, measurement approaches, and limitations. So we'll start off with the most commonly studied outcome, which was emotional well-being, reported in 25 studies. This is expected since VR often emphasizes engagement and enjoyment, naturally highlighting affective experiences. Most studies use self-report tools like the PANAS and STAI, while some also included physiological measures such as EEG, heart rate, and blood pressure. Reported benefits included improved mood, relaxation, and reductions in anxiety or negative affect. These physiological results sometimes confirmed calming effects, but not always. Overall, the evidence is promising. Immersive nature reliably supports short-term improvements in emotional well-being, but the field needs more standardized sensitive measures and clearer insight into which design features drive these benefits. Next is stress reduction, which was the second most reported outcome found in 21 studies and is especially relevant in healthcare and workplace settings. Measures included both physiological indicators, heart rate, blood pressure, EDA, EEG, and psychological tools like the Perceived Stress Scale and STAI. Overall, participants generally felt less stressed after immersive nature exposure, and many physiological markers also declined, though subjective and biometric results did not always align. These results highlight both the promise and complexity of stress reduction in immersive nature, but more integrated measures and larger, more diverse studies are needed to fully understand the effects. Next is restorative benefits, which were reported in 16 studies reflecting psychological relief such as mental clarity, reduced cognitive load, and feeling refreshed. Most findings came from self-reports, especially the Perceived Restorativeness Scale, with outcomes strongest in environments featuring biophilic design, realism, and multisensory elements. Some studies also found physiological or cognitive improvements, though results were inconsistent. Overall, restoration appears meaningful but highly dependent on design quality, with the need for standardized measures to link subjective reports to performance outcomes. Cognitive performance was also examined in 16 studies, fewer than stress or emotional outcomes, but with strong relevance in education, healthcare, and workplace contexts. Measured through tools like the NASA TLX performance tasks and eye tracking, reported benefits included reduced cognitive load, enhanced creativity, and in some cases, improved short-term memory. However, results were mixed. Some studies showed no memory gains, and others reported higher immersion without performance improvements. So this makes cognitive performance a promising but underexplored area, especially for applied settings like classrooms and rehabilitation. Attention recovery was the smallest theme with only 5 studies, but still conceptually distinct. Unlike cognitive performance, it focuses on regaining focus after fatigue, which is highly relevant in today's multitasking world. VR nature has been linked to lower arousal, greater visual engagement, and self-reported reductions in mental fatigue. Task-based evidence, like the sustained attention to response task, also suggests improved sustained focus, especially in environments with moderate plant density. Overall, early findings are promising, but this remains an underexplored area as well. And lastly, nature connectedness holds a distinct place in XR research. Unlike emotional well-being or stress reduction, which reflect temporary states, connectedness captures a deeper sense of identity, empathy, and belonging. 8 studies measured it directly, consistently showing increases after VR exposure, often with tools like the CNS or inclusion of nature in self. Physiological or cognitive evidence is limited, and no studies have tested persistence over time. Overall, connectedness is underexplored but powerful, pointing to XR's potential not only to shift momentary feelings, but to reshape how people see themselves in relation to the natural world. Future work needs longitudinal designs and broader cultural perspectives to fully realize this potential. So across these 6 themes, we see consistent short-term benefits, especially for emotional well-being and stress reduction. But we also see inconsistencies. Measures don't always align, cognitive and attention outcomes are underexplored, and connectedness is rarely measured directly. These patterns point us to our third research question, which is what gaps remain in this field and how can future work move it forward? So here's where the field stands today and where it needs to go next. We saw clear gaps, a heavy reliance on VR, overuse of visual and audio channels, minimal interactivity, short-term lab studies, and a narrow focus on student samples with self-report measures. But these are also opportunities. The next phase of XR nature research should embrace AR and MR for daily life interventions, expand multisensory design, move toward embodied interaction, and adopt longitudinal, ecologically valid protocols. Importantly, we need to diversify participants and test whether nature connectedness mediates emotional and cognitive benefits. So in short, XR nature has shown strong promise, but its future impact depends on addressing these blind spots with breadth, depth, and diversity. In a world where access to nature is shrinking, XR may become one of our most powerful tools for reconnecting with the natural world. Thank you.
Okay. Any question, comments?
Hello, thank you for your interesting talk. I was wondering, this is maybe a question that was also asked in the first presentation. Did you also check whether some of the studies looked into connecting with more photorealistic nature environments, maybe even recorded with 360 cameras instead of computer-generated?
I think it was mentioned in one of our findings, but there is a lack of there is a lack of research that shows research in that area, and especially with like even multisensory design or like realism. But we did see that some studies did show that more realistic nature does have better benefits, but I think there's definitely a lack of research there.
Yeah, I could imagine it makes a difference. Thank you very much. Looking forward to future work.
Thank you.
Thank you. Yeah.
Thank you for this presentation. According to the review that you made, can we take it for granted that the use of biophilic design improve the well-being in various contexts? Because as you know, it's very difficult to accomplish tasks to demonstrate that this biophilic design can have positive effect on the well-being. It requires a very long study. So can we, after this review, take it for granted so we can concentrate now in this research to optimize the design, so make 2 plants instead of 1, something like this?
Sorry, can we take it
for granted that for something that it's sure that the biophilic enrichment improves the well-being, or should we again demonstrate it? Other studies are needed.
Yeah, so I think the intention of this review and my greatest takeaway was that we do need more studies that show, all the different elements that go into what creates the benefits for the user. I saw some studies that said the plant density also, it depends how it affects the person's well-being. For example, the more plant density doesn't just mean it's better. There's a moderate, there's a perfect level of plant density that actually does benefit the participant. So I think there's definitely a lot more research that is required in this area.
Thank you.
Thank you. Other question? Maybe we can take one more. Okay, actually, I have I have a question. If my understanding is correct, well-being has a social aspect in addition to emotional, cognitive, and physical aspect. So, but that nature a little bit, I don't know, far from social things. But did you find anything relevant to social well-being?
Social
things. Now like just only the environment
right.
to the individual,
Mhm.
but well-being consists of physical, emotional,
Right.
cognitive, and social
Mhm.
well-being. So did you find anything?
I think
related?
social well-being is hard to measure. So in the studies that I've seen, we saw, physiological or cognitive or psychological measures. But that is an area that I am interested in. For example, gardening therapy, it's very good for, social interaction. So that's an area that I am exploring. In the studies, I don't think there were any that specifically, measured like the level of social well-being. That, yeah. So I do think it's a very interesting, future study to do.
Yeah, thank you. Okay, so let's close the session. Thank you, all speakers again.